If you were to drop a credit card into a beaker of acetone, the familiar plastic melts away to reveal a dense, intricate web of copper wiring surrounding a tiny silicone core. This object is a batteryless microcomputer disguised as a flat sheet of plastic. This complex circuitry is the result of a 60-year arms race between the banking industry and the criminals trying to bypass its defenses. Every major hardware change to your wallet has been a response to one repeating cycle. Convenience usually comes at the expense of security. To break that cycle, engineers look toward a piece of Cold War surveillance hardware, originally designed for Soviet espionage. For decades, paying on credit meant waiting. A cashier had to place your card into a mechanical imprinter, physically stamping your raised numbers onto a carbon copy paperslip that would eventually be mailed to a bank for approval. By the 1960s, banks needed a faster way. IBM engineers looked at audio cassettes and realized they could iron that same magnetic tape onto the back of an ID card. The magnetic stripe made transactions near instant, but it had a vulnerability. It stored information as a permanent, unmoving sequence of magnetic ones and zeros. Because the code never changed, anyone with a card skimmer could copy it in seconds. By the early 2000s, criminals were swiping millions of numbers and cloning duplicate cards, costing the industry hundreds of millions of dollars every year. The magnetic stripe eliminated the checkout bottleneck, while leaving the card's sensitive data exposed and unprotected. The banks retaliated by introducing the EMV chip. This tiny metallic square is an active processor designed to replace static data. When you insert it into a reader, the chip uses a secret cryptographic key buried deep inside its silicon to generate a unique, single-use encrypted code. Even as a thief intercepts that exact code, it cannot be reused for a second transaction. It stopped counterfeiters, but it required a continuous physical connection to the terminal. The communication between the chip and the bank added an average of 10 seconds to every purchase. While the chip made transactions significantly harder to forge, the added friction slowed down retail checkout lines across the country. The solution to this bottleneck was near-field communication, or NFC. It allowed the security of a microchip to happen at the speed of light. The physics of NFC trace back to a device planted in the U.S. ambassador's Moscow office in 1945. Nicknamed the Thing, this Soviet listening device sat undetected inside a wooden plaque for 7 years because it had no power source of its own. It lay dormant until Soviet spies aimed a radio beam at the building from a nearby location. When a specific frequency hit the bug's antenna, the energy from the external signal induced an electrical current, bringing the circuit to life. As the Americans spoke, their voices vibrated a thin metal diaphragm. Those tiny movements altered the electrical properties of the bug, which modulated the radio wave bouncing back to the spies, carrying the audio of the conversation with it. Today, your payment terminal acts exactly like the Soviet spies. It projects a changing magnetic field. When you bring your card close, that field cuts across the copper antenna inside, generating enough electricity to power the chip. Drawing only on that borrowed power, the microcomputer encrypts your transaction and pulses its mathematical signature back to the reader instantly. Tapping to pay is a high-speed, secure dialogue powered by Cold War physics. Because NFC communicates wirelessly, it does open the door to digital pickpocketing. A thief can carry a hidden terminal on a crowded street, brushing closely past pockets to trigger a payment. However, a proximity scan cannot extract the secret cryptographic key. Without that key, thieves cannot clone the physical card. The most effective defense against unauthorized taps is turning on transaction notifications in your banking app. You will immediately see if an unexpected charge hits your account, allowing you to freeze the card. The final evolution moves the card into a mobile wallet. The phone generates a virtual token instead of transmitting your actual card number, and it locks that token by biometric authorization, like your fingerprint or face. Moving our finances into our phones combines the speed of inductive power with the security of biometric encryption. If you've made it this far, thanks for watching. Please consider subscribing to Deep Dive Daily, hitting that like button, and dropping a comment below.